My name is Gera Goft. I'm from Radware CTO office, and I'm leading the system architecture design and implementation of Defense4All. And this session is on Defense4All hands-on. Now, we won't be doing any installation of that kind, but my goal is to take you through the details of how to install, run, configure Defense4All, how to invoke its API, CLIs, depending on the time we're going to have. I'll start with some background and motivation about the need for security attacks mitigation. Overview about Defense4All, and then take you through installation, invocation, and configuration, followed by a CLI overview. There is also a REST API, which is very similar. And then describe a little bit about attack detection and mitigation in Defense4All. We may or may not get into the architecture details depending on the time. And at the end, we will have some summary. So, to those of you who are not that familiar with security attacks, cyber attack campaigns, denial of service attacks, in recent years, those campaigns are getting longer, stronger, and more sophisticated. And therefore, network security is becoming an increasingly important theme in any network. We believe that denial of service protection should be a basic element in every network, where protection we mean attack detection as well as mitigation. Basic attack detection can rely on RAID-based anomalies. So we learn traffic, normal patterns, and then if there is a deviation over a period of time, we declare an attack. Attack mitigation could be anything from reporting through the redirection of traffic to mitigation devices, which then clear the traffic and return only the clean traffic back to the network. Traffic redirection can be selective. Namely, we can redirect only the attacked portion of the traffic. So for instance, if there is attack on TCP, we redirect only the TCP traffic, while UDP and all other traffic remains on the main course. We also believe that denial of service protection should be extensible. So if desired, users can have more advanced, sophisticated mechanisms both for detection and then mitigation policies. Okay. Radware, a brief overview about Radware. Radware has a best-of-breed attack detection and mitigation systems in the areas of denial of service, including RAID-based and, of course, behavioral-based immediate detection and evolving detection of attack details, and therefore mitigation that can be more and more pinpoint to the point of attack. We believe that we can unleash the full power of SDN by utilizing it both in detection and flexible, as well as efficient mitigation of attacks, by transforming the theme of attack protection from devices in the network into a network-wide service, where the network itself helping in detect as well as mitigate certain attacks, such as block traffic and redirect to distant scrubbing centers. Okay. So what is Defense4All? Well, in short, it's a security SDN application, a full, complete security SDN application, one of the few existing today. This application aims to detect denial of service attacks against selected networks or servers. And once attacks are detected, it drives mitigation. And I will get into more details of what it means to drive the mitigation of those attacks. Okay. On a daily basis, Defense4All monitors traffic by periodically reading counters installed in certain network location. It uses the OpenDaylight controller to retrieve latest counter readings, and then it declares attacks if there are anomalies relative to learned baselines. Okay. Once an attack is declared, traffic can be redirected to mitigating devices, or reported, or blocked, or any other mitigation method. And at the end of the attack, traffic redirection can be canceled and return to normal flow. We promote a comprehensive SDN applications ecosystem. Defense4All has a framework. So you can use the framework and replace the Defense4All application by any other application that can leverage those same services to OpenDaylight APIs and other network devices. And Defense4All application itself is highly pluggable. You can add or replace detection mechanisms, mitigation drivers. You can pretty much do anything in there. That's Defense4All. Placing it in the network, you can see the SDN network, or can't you? Pointer options. No. You can see the SDN network to which a set of servers are connected and clients accessing those servers. That network is managed, controlled by the OpenDaylight controller. And then the Defense4All SDN application uses the northbound REST APIs into the controller to do several things, such as install counters and perform traffic redirections. Optionally, we can have attack mitigation systems, mitigation devices attached to the network so that traffic can be redirected to those devices when attack strikes. Defense4All itself presents its northbound API by means of REST and CLI, and we will get through the CLI part today. Okay. Any questions so far? Yeah, we'll get to that in more detail. In short, normally traffic flows from clients to servers without any redirection to attack mitigation system. So they're placed out of path. For the attacked portion of the traffic in selected protected networks or servers, if there is an attack, then Defense4All does the magic to redirect traffic and return traffic through the mitigation devices. All right? Black holing the traffic is one option of mitigation. You can have several options. The mitigation drivers, as we will see later on, are all pluggable. So we can have many of those in the same Defense4All, right? So one mitigation driver could say, let's redirect traffic to a mitigation device. Another could say, let's just black hole it, you know. And the third one could just say, let's report it or redirect it to a remote scrubbing center. All right?
The first question is, what kind of counters does OpenDaylight have about networks or something that flow as flow piece? And then as far as how it sends flows to the attack mitigation system, is that on source destination flows or transaction rates, SYN packets, PIN packets, whatever?
Yeah, we'll get to that later on. Yeah, let's wait with this question.
Do you exclusively use the REST API, or do you use any of the
In the controller?
Yeah.
Today we use only the REST API. We plan to use the controller APIs more intimately in the future, namely integrate at least some portions, right, of Defense4All inside the controller, and maybe we may want to consider in some installation put the entire application inside, you know, collocated with the controller co-bundled. That's a good question. Today, we focus on redirecting traffic from switches or routers to directly attached mitigation devices. All right. So that may target to certain types of customers, but some customers may be just okay with local redirection, while other customers may want to have larger scrubbing centers. We do not presently support redirection to larger, to remote scrubbing centers having, zillions of mitigation devices. But we want to rely on more advanced services that are being developed in the controller for stats collection and more importantly, the redirection services, which would allow then redirection to remote locations.
Looks like from this diagram that it's actually an enterprise network.
All right?
Yeah, I say that it looks like it's an enterprise network. And the question is, can I use it tomorrow? Orange carrier, such as Orange or Verizon, or I don't know, another big data center, Facebook, or
Yes, actually, there are several. Again, there are several types of customers that are being addressed and considered. Service providers, enterprises, cloud providers, each having similar but could be different requirements in terms of capacity, what is being protected, you know, the the type of mitigation required. Like service providers, they may want to protect their infrastructure. So they just may want to say, I want to protect that link. Whatever comes through that link, I want to protect it. I don't care about the servers. I just care about my networking infrastructure. So that's one use case. Another use case is a data center, right? Where a customer may want to say, I want to protect my servers, you know, and select their protected elements according to destination IP addresses, ports, and protocols, etc. But we do not, in the architecture itself, we do not limit anything. You know, the initial implementation may be limited, but it's just a matter of coding, right? The architecture itself is very, very flexible. Okay, let's move on and have a few more questions later on. So inside the OpenDaylight structure, here are the relevant portions. The DDoS protection is the Defense4All. Today we use the basic flow configuration and a retrieval of statistics API from controller, but we would like to move away from that lower level to more abstracted API by means of stats manager and traffic redirection services. Okay. Now, this diagram shows the various use cases we touched just a minute ago. If you look at this network, you can see the first type of protection up above, protecting the service provider infrastructure. So you can set up the links and remove attacking traffic as quickly as possible right there at the entrance of the network. Okay? And you may have locally connected mitigation devices. In this case, Radware's Defense4All, could be anything. You can also have a remote redirection for larger attack campaigns to scrubbing centers, right? Located somewhere in a scrubbing center containing many Defense4All or any other mitigation devices. Down below, there may be customer network, and the service provider could be offering service to customers to protect their business. It could be enterprise, it could be, you know, anything similar, data centers, etc. Again, there are many use cases, and we wanted the architecture to be as flexible as possible to accommodate all of those use cases, either now or in the future. Okay. I'm not going to go through all the gory details about how to install Defense4All. um, but just the important highlights. You can find the installation configuration instruction in the wiki, right? We support today Red Hat 6164 CentOS 6164 64-bit, as well as Debian 7 and Ubuntu 12. The installation consists of 3 parts, right? You need to have JDK or JRE, whatever you want to do. You need to install Cassandra, and we have some guiding steps how to quickly install and set up Cassandra, at least for the general setup. And then you need to install Defense4All, which is basically 2 packages. Defense4All Core and Defense4All CLI. There are 2 packages for each of the types of supported platforms. To run Defense4All, very easy. You just do start or restart in this case, and you can check the status, whether it's running. When Defense4All runs, it automatically does the magic of configuring whatever needs to be configured in Cassandra or other environment setups. Okay. Now I'd like to talk about the initial configuration using the Defense4All CLI. First, you need to tell Defense4All the address of the hosting machine it runs on. Then you need to tell it what controller it should use, what OpenDaylight controller, its connectivity details, etc. Then you need to tell what mitigation devices should be used that they are attached to, to switches, relevant switches in the network. This step is optional. If you don't use any mitigation devices, you can have other types of mitigation, like reporting or black holing or whatever. In the next step, you have to tell Defense4All what SDN switches or routers it should use. And finally, and that's the most important step, you tell what protected networks, or in short PNs, you want Defense4All to protect. Right? You can have as many as you want to, up to, I don't know, many thousands or millions. It's not really important. It's just limited by the number of flows you can configure in the control, in the switches in the network. If you want to clear everything, there is a quick step, which is to do a factory reset. So a factory reset just wipes out everything, any configurable as well as any dynamic data in Defense4All, and also in the configured flows in the network and configuration in mitigation devices, etc. Any questions on this slide? Attack mitigation system or mitigation device? Yeah, good question. That there is a slide coming up, a few slides ahead. In short, the basic philosophy in Defense4All is that you put every configuration data, as well as most of the dynamic state which you want to preserve, you put it in Cassandra. So then you decouple, completely decouple compute logic from data and state and all that stuff, and then you can restart or fail over, do whatever you want as quickly as possible. You can, you get all the scalability, high availability, all in there. Okay. Any more questions on this slide? Okay. A few configuration notes. We normally, at the end of the day, we shouldn't have any order in which we configure the various elements in Defense4All. Today, first release, we have some limitations. So we have the order of steps to perform. So if you want to change a step, you have to first remove everything that comes after that step, change it, and then return everything that comes above. That's a temporal limitation, and it should be lifted in future releases. When we remove an element, we wipe out all its configuration data, as well as any dynamically obtained data, such as, for instance, if we learn baselines for a given PN, and we remove that PN, we forget about the baselines, and once it is reintroduced, we have to require those baselines once again. In the future, we want to have more granular types of reset. Today, we have factory reset. We would like to have, for instance, soft or dynamic or pinpoint resets for various portions of the system. This is not supported in this release. Okay. CLI overview. We have I don't know, 10 slides on that, but this is basically what you use to configure Defense4All. You can invoke the CLI from console or use SSH. Basically, all Defense4All commands start with control ops, then the name of the command, and all the parameters that should be passed. There is a notion of how the parameters are formed, because some fields are simple, some fields are composite. So rather than using subshells or using JSON strings, we just did something quickly, and it is defined here. For simple fields, you can use field name equals field value, so we know what fields we're talking about. For composite fields, we need to qualify that. So you tell the name of the containing field, then the name of the subfield and its value. And for list, we have several of those. We have to specify the list name, the list element label, and then the composite field and composite subfield, and then the value. A bit tricky. A few examples make it very simple. Okay, first, help. If you type control ops help, you get a list of all the subcommands that are supported. And if you try control ops help for given command, you get that. Now, you can set host address using the control ops set host address and the name of the host address. You can get it You can terminate control apps by simply typing in control apps terminate and specifying the scope. Now, the scope can be either this instance or a cluster. In first release, Defense4All is a single instance. In the future, we want it to be clustered, okay, with all the distributed sharded Cassandra data. We want it to be clustered, and therefore, when you want to terminate, you need to specify what you want to terminate, whether you want to terminate the entire cluster or any given instance, and you can have that choice. In a single instance, it doesn't matter, so it's the same. You can also specify control app reset for for a given level. In this release, a factory reset is supported. Soft and dynamic are not so much, but they will be supported in the future. Okay. Any questions about the CLI so far? Okay. Flight recorder. In Defense4All, we record all events, important events, security events, operational events, failure events, and we can keep them until we exhaust the disk space, basically, which means that we can easily store a months of data. And we allow the user to retrieve any portion of that data of those recorded records. The first CLI, control ops flight recorder events or FR events, specify a daytime range in which to get the events, optionally bound by some maximum number, and then specify an optional list of filters. Each recorded event has a type or a category, and you can specify what you want. If you want just the failure events or the security events or all of the events or any subset of those filters. If you want to specify several filters, you have the example how to do it in there. The format of the return records is simply event time, event type, and the textual data of the event. Okay. You can also get the latest events, and you can optionally specify a limiting number in the same filter list. You can throw all those events that you want into a file and do whatever you want to with that file later on. And of course, you can clean up those old events. Any questions about flight recorder? No. Yes, go ahead. All the events are stored in the same Cassandra server, which can be clustered and sharded and whatever you want to. So as many as you want to have. What?
As much as you have.
As much as you have. If you want some redundancy, you have to account for that. But even on a single instance, you take a single machine, half a terabyte of memory. You do the math. You can store, year or 6 months of events, and you can do any analysis you want to. What?
Depends on how many events you have.
Well, that's Well, normal assessment, it's in that range. Okay, controller. To set up a controller, we need to provide its host name or IP address, label, management address and port. Not sure. Okay. Oh, that's the IP address. Okay. Host name is the optional host name. Management address is the IP address. One of those is fine. Then you have to specify username password to connect to it. You have to specify what you want to use it for. You can use any given controller for stats collection, for traffic redirection, or both, or you have to specify. And there are defaults, of course. There is an optional list of properties. Today, we do not really use it, but it's an option. Any family of CLIs, configuring the various elements has an adding the element, getting it, getting all the elements, getting their count, and removing the element. So it's straightforward. The next one is a net node. It's more complex. The net node is our modeling, first of all, over physical switches or routers. In the future releases, we want to model it after more abstract types of network elements, such as if we use VTN API, then we can model net nodes over VTN networks or subportions of those networks. There are a few other examples. In the simple setup over physical switches, we look at the switch and we identify the north ports, the south ports, and the ports that lead to mitigation devices. And we can have a set of protected links. There are two types of switches which we consider, SDN native and SDN hybrid. For SDN hybrid switches, our life is a bit easier. Once we do our counting, we can set the action to something like send to normal, do whatever normal routing you want, and we are done. With SDN native, we have to sweat a little bit more. And we don't like to sweat, at least not in the first release. So what we've done is basically this. We've identified protected links. So if you want to redirect traffic from a switch to Defense4All, you use that switch mainly for that purpose. So you identify pairs of ports, input-output ports. So it becomes more or less a bump in the wire. But it allows to quickly determine which port to output data of any given packet. To model that, we have the notion of a net node. Network is more general, but those same patterns repeat in more abstract environments as well. So you have control apps at net node. You have to specify its label, ID, type, management address, port. You have to specify whether it's a SDN native or SDN hybrid. the AMS connection is basically the name of the mitigation device and 4 connecting ports. In this example, 1, 2, 10, 11. Okay, and you have to specify north and south ports and protected links, and you're done. Okay, it's a bit complex, but you use one example and it becomes easy. And we have some examples in the wiki. For AMS, similarly, we have to specify its label, brand, version, username, password, and specify whether it's used for stats collection for the version. We want to allow the option that the user would base attack detection on either or both of SDN installed counters as well as mitigating devices signaling attacks. Now, for those devices to signal attacks, they cannot just sit out of path. They either have to sit in line or in copy mode, right? So we want to support that as well. So in here, you can specify what it should be used for, right? And then you have the management address, management port, frequency or preferred frequency to check health of those mitigating devices. We haven't implemented that in the first release, but the goal is to periodically monitor those mitigating devices as well as the links. And in any case of failure, recalculate what mitigating devices, alternative mitigating devices could be used for the same attack. Okay? Question about mitigating devices? Yes, no. I hope I'm not running too quickly. Good. And finally, the Holy Grail, the PN. This is the business, right? This is the main purpose of this SDN application. Our goal was to provide as simple as possible configuration, simple touch and forget configuration, that everything else is automatic. And the goal was to provide just a minimal set of parameters, and everything else should be realized and configured and learned by itself. So we have the label, the PN label version of IP, IPv6, IPv4. Virtual network ID. Virtual network ID is something that can optionally be used, especially in more virtual setups or abstract or overlay setups, in which over the same network we may have several overlays. I can share the VTN example, right? With VTN, we can have several VTNs, so we need to qualify the protected IP with the VTN, and that would be put as the virtual network ID. Then we have destination address, which could be any /32 or anything less, and that less is specified by destination address prefix length. So we could be protecting any range of addresses. In this release, we do not support confirmation of before we do mitigation, namely traffic redirection, for instance. But in future releases, the user should be given the option to state, I want to do it automatically, or I want to confirm before we redirect traffic. Protection SLA is left to the future. It's empty in this release, but the goal is to specify how important this protected network is, especially if we are constrained with resources, quality of service, etc. Optionally, the user can specify the label of the detector to be used for that particular protected network. If you remember, I said earlier that Defense4All may have several detectors configured, installed, right? And for any given protected network, we can let the user select which detector to be used. Of course, there are defaults. We can optionally specify if it's SDN, OpenFlow-based detection, but it's not mandatory. A little bit about symmetric diversion. When attack strikes, we can divert inbound traffic, or we can divert inbound as well as outbound traffic. In some types of attacks, security attacks, it is important for the mitigation device to see both sides, for both directions of the traffic, to properly mitigate those attacks. Okay? So the user is given the choice to specify whether both directions of the traffic should be redirected in case of attack, or just the inbound. Symmetric means both, asymmetric means inbound. Now, the user can optionally specify threshold percentage, static threshold percentage over which attack should be declared and traffic should be, for instance, redirected. That goes in contrast to normal dynamically learned baselines on top of which attack is detected, but the user is given that choice. Okay. Optionally, the PN can have certain properties to be set in mitigation devices to properly mitigate those attacks. It's an optional parameter, and it can be left out. The net node label, actually there can be several of those. Traffic of a protected network can flow through several switches in the network. So we want the user to specify, in this release at least, we want the user to specify in which switches that particular traffic flows. We can learn it, of course, but it's fairly easy to provide that. And there are, of course, the default values. Okay. Important point to mention here: when we remove a protected network, it's a complete removal. It includes not only the internal state or any configured data in Defense4All, but it also includes removal of any flows configured in any of the switches, removal of any configuration in mitigation devices, and obviously removal of any traffic redirections for that PN. Any questions about this API? This is perhaps the most important one. Okay. There are two more sets of CLIs to obtain any active attacks and any active mitigations. We distinguish between the two. Attack is a mere declaration that here is an attack, it's a record containing all the information about what is being attacked, the detectors detecting that attack. Mitigation contains details about the mitigation of that attack, including which is the mitigation driver, if traffic redirection goes on, what are the details of that. Okay. And that pretty much concludes the CLI section. In this section, I would like to go briefly over how attacks are detected, mitigated, a few screenshots, just to get the feel of what is going on. Right? When we monitor traffic, we install traffic counting flows in the specified switches, specified net nodes. And we install them for each protocol. There was a question earlier. For each configured protected network in every network location relevant to that protected network. Then periodically we read statistics from those flows. We aggregate them, we learn them, and we maintain that at the counter level as well as at the aggregated level. There is a reason for that. More precision, more scalability, but I will not get into details at this time. In any case, each time we read, we get. Was there a question? No.
Where is it getting the flow information from?
We install flow entries in special locations in the specified switches, and then we get from the controller all the statistics, and we filter out to get the statistics on those flows. I don't know. I think it depends on the particular switch, but I think in some cases, well, I'm not going to get in.
So
yes.
Defense4All gets the flow information.
Exactly.
Which then gets to
Right.
Yeah.
So what we construct basically is what we call a traffic tuple. We get a single tuple for all the protocols, for all the ports relevant to what we want to read And for every protocol, for every port, we get a value of bytes, latest bytes, and latest packets. We also have a flag specifying internally whether this vector value is used for traffic learning. Some of them are, some of them aren't. And there is also the direction. This way, this way, this way, this way. So we can pretty much learn everything, and we can aggregate according to those vectors. Okay. In normal flow, the upper graph shows traffic from the client into, say, a switch, an SDN switch, to which on the left we have a mitigating device connected out of path, and down below we have the server part, the traffic that flows to the server. As you can see, normal time, the mitigating device is silent. Traffic flows from client to server, and you can see the same incoming as well as returning rates of the traffic. Let's see what happens when we want to detect attacks. We continuously learn the averages and the baselines. As I said, for each traffic protocol, directions of every PN. We declare attack if there is a continued deviation, significant deviation, from the normal rates and averages. Now, this detector is purely based on rates. There are other detectors. In Radware, we have other more advanced detectors, but I'm not going to cover them here, of course. This one is basic. It's based on rates. And if we sense a deviation from the normally learned traffic, we declare an attack. Okay? That attack will remain as long as there is at least one detection from any of the detectors. Now, Defense4All is as I said earlier, it's purely, it's highly modular. You can have additional detectors, you can have additional external detectors, all of which could be signaling attack detections. And we have a module that aggregates all those detections and manages the attack life cycle. So as long as there is at least one detector with a non-expired detection, the attack goes on. Otherwise, it is ended. To mitigate an attack, these are the steps that we should do. We should select the mitigation device or devices, and for every switch, there may be a different device which we select. So we can have redirection, in many locations to different mitigation devices. Then we want to optionally configure those devices before we redirect traffic to them. Finally, we redirect traffic, and we continue monitoring using SDN, using optional signaling from those mitigating devices saying the status of the attack. Okay, when the attack ends, we want to cancel everything. And this is how it looks like on a switch. is just an example of traffic redirection and return from a mitigating device. Now, what you can see up above is a rate attack, denial of service attack. You can see the rates going up, right? And once the attack is detected, traffic is redirected to the mitigating device. So now you can see the traffic in that mitigating device, right? On the server side, initially, you have the high rate, but as soon as the attack is detected, it is mitigated in a matter of fractions of a second. It's that quick. Detection is configurable. We can detect in 10 seconds. We can detect in less. We can detect in more. But once we detect it, the traffic redirection is split second. Go ahead. If you could speak up.
What does it do when it comes to mitigation box? Again, it is like
That depends, I guess, on the policy in the mitigation device, right? A good mitigation device should block any attacking source, right? And pass all the rest of the traffic, the legitimate traffic.
What about distribute? I mean, people spoof IPs all the time. Attackers spoof IPs all the time.
That's the smart of the mitigation device. Okay, that's and I know in Radware, Defense4All is capable of continuously monitoring the attack and evolving its detection of what is going on. The idea is that we want to start mitigating as quickly as possible, even if we are not 100% sure what is going on. We want to start it, from first second or from first 10 seconds. Later on, as soon as we learn what is going on, we can, leave more sources as good sources passing on, blocking only, some of them.
It's an effective denial of service if you can attack a mitigation system and have the mitigation system block customers. That you're basically denying service.
True. If you are blocking everything, you haven't done your job. But the blockage should be selective and depends on the quality of the mitigation device.
Sure. Okay. And that's where it is, the mitigation device.
Yes. So after a while, you can see that the traffic to the server is good. It's back to normal, and it stays that way until the attack is over. Now, when the attack is out, we still do the redirection to the mitigating device, but now we can see that both the client side and the server side traffic is normal, and after a while, we end mitigation, so you can see zero throughput at the mitigation device, and everything is back to normal. Any questions so far?
From a management perspective, you still need to manage the mitigation device, right?
Well, that depends. I could say the simple question is yes, but. it's a but. We believe that a single point of control should be, used as much as possible. Now, if you have a driver, and everything, as I said, is modular, you can have drivers, right? And in the adding mitigating device at AMS, as well as at PN, you can specify all those properties that hint you what should be configured. Now, if you configure all that through the driver to that mitigating device, you pretty much are good with almost single point of control. And that's very important. I mean, you can always, hook up externally and tune your mitigating device if something really strange is going on. But most of the time, you should be okay with just this path. That's the philosophy, at least. Okay, any more questions? Go ahead. So, I'm not sure what you're asking.
Specifically, I can talk to that. So, sort of an entry step, there are things you might want to box like that to take, like volumetric attack, you might want to redirect it on your network, taking care of it at the edge or something like that. Something, but we also have an SDN application files true SDN application of the link direction.
Yep.
People, it's very easy to deploy in their networks and carriers. Yeah, we're looking at, we're looking to build the northbound interface to change RPF filters on our edge for computer so that we can mitigate these attacks. Our attacks come from everywhere. We get North American space coming into Europe, European space coming into North America. Can't really turn on RPF with feature problems in our core. Effectively, what we'd like to do is be able to do that RPF check dynamically with these programs, RPF filters, dynamically as the attack come in. Then you know exactly where the specified attack is coming in.
Right.
And you know that you can block these hosts on the other side.
Right. So it's both ways, yeah. PN lifecycle, right? It starts from anything that is unmonitored, peacetime, where you collect statistics and look for attacks, detections of attacks, announcement before the traffic redirection or any other mitigation. An optional awaitings for user confirmation of any mitigation methods for that attack, and finally the mitigation itself. When everything is back to normal, then everything collapses to peacetime level. When you remove the PN, you go to ground zero. That term. A what? As a user? Well, today, that's a good question. We would like to have both methods, push and pull, to get user notified about attacks. Today, we support the pull method, namely the user can type in the CLI and ask what attacks are going on. Push method is something that we still need to implement by any means, whether that's SNMP, traps, events, emails, whatever. Yeah, that's a good point. Okay. I'm not going to go into all the details of the architecture, just the highlights. Okay. As I mentioned earlier, one of the basic philosophies that we have is that everything is modular, should be replaced by any other component. The application itself could be easily replaced or added by another application. So the security SDN application could be replaced by other applications. And therefore, you can see that Defense4All application is a box, is represented by a module, so the framework. The framework takes out all the common denominators and providing all the services, such as repository services, logging services, clustering services, web services, email services, anything you want to. But more importantly, the SDN driver services. So if you have multiple applications to various network portions, the OpenDaylight controller, mitigating devices, other devices, you want to put that in the framework so you can have multiple applications. That's one point of emphasis I wanted to make. The other point of emphasis is, as we briefly touched earlier, the repository services. We have a convenience library over Cassandra, in fact, the client library of Cassandra named Hector. Any durable state should be stored in those repositories, right? You can think of repository as a table in a database, right? Every module can have 0 or more repositories of its own. Then, with all those repositories, we can have all the replication, caching, distribution in the framework, in the user configuration outside any application logic. All right? So that's powerful, which means we can, deploy it on any environment, any topology, and it should work, right? So decoupling the compute state from compute logic. It means scale-out clustering durability, and it means that we can proactively increase robustness outside the application logic. How? For instance, we can have the framework periodically recycle the applications, thus taking away all the aging bugs. Every 5 hours, just recycle, for instance. Another small point is the health tracker. Actually, I'm not sure how much time we've left. Let me just push on. The application itself. Here is what I'd like to emphasize in the application architecture. You can see the OpenDaylight reps or drivers, which are pluggable. You can replace them. You can use anything else, any other version or any other abstraction or overlay in OpenDaylight. The detector is pluggable. The mitigator driver is pluggable. So you can replace everything. Oh, by the way, I forgot to put it, but the AMS rep or driver is also pluggable, of course. Okay. Okay. we're approaching the end of this session, so I'll try to summarize. In terms of security, the main benefits of Defense4All, we wanted to have a simple, abstracted provisioning of anti-DOS protection service. We wanted better out-of-path, denial of service, detection and mitigation of attacks with as much as possible zero touch. I want to be scalable, precise, and faster than any solution today. So we utilize the native SDN programming to get our counters, so we don't need any special devices. And also do traffic redirection, which can be done, it's straightforward, fast, it's there. You don't have to sweat a lot. We wanted to have a central security control, allowing efficient management of network and application detection, because once you move out from the floor, you can see the entire network, and you can reason more. You can have smarter reasoning about what is going on. You see the entire network. You can take actions of the entire network. It also means lower solution costs. And in these cases, simple attacked traffic redirection. In terms of the architecture, the main benefits, all the non-functional requirements are outside the application logic, which means it is more robust, it's more flexible, it's more scalable. Or basically, it is designed and architected for all the ilities, right? You can look up what those are. For future contribution, we would like to have at least some basic UI, web UI, and we will look for contributing that. We would like to exploit the stats services and redirection services that are being implemented in OpenDaylight controller, which would allow us simply richer topological options when we do redirection into remote scrubbing centers. And it would also allow us simpler configuration in some cases. Obviously, we always want better maturization, more testing, and another functional usability enhancements. And one of the more important points, we seek for a collaboration. We would be happy, if we have additional detectors, people implementing additional detectors, mitigating drivers, plugging in reporting, event correlation, and even other SDN application inside the same framework. It's in there. You can leverage it. Defense, yeah, sure. Sure. Java application. You could create your own Java application, you put it in the framework, and you immediately leverage all the services provided by the framework, including all the control and common look and feel that the user would get. It's not in the Defense4All application. It's either instead or side by side. Right. Today, the framework can accommodate, the Defense4All application, but we would like the framework to accommodate any other application, including multiple applications. So you get the same look and feel. We even envision in the future collaboration among those applications. Okay. I'll skip that. So, denial of service should be a basic part of every network. That's our belief. We see that SDN transforms attack protection from network service devices to the complete protection by the network itself. So we can unleash the full power of the SDN network. And we talked about Defense4All, and we are welcome everybody to come aboard, use it, contribute to it. That's it. So, any questions? Sure. I'm sorry, come again? Okay. Thank you guys for staying that long.